Hello everyone. In this video I'm going to be looking at simplifying or dividing complex numbers in rational expressions. In this case I'm looking at the second type. There's two types of simplifying or dividing complex numbers. The first is when you have a single term in the denominator which has an I attached to it. The second is if you have two terms in the denominator, one of which has an I with it. In this case, my 7 minus 5i. I want to look at this, and I'm going to specifically start by focusing on the denominator. To solve problems like this, we're going to look back at factoring, difference of squares. If you remember, that's where we say if I have a squared minus b squared, it factors into a plus b and a minus b. Let's try that a little neater. And these are referred to as conjugates. A plus b and a minus b. Conjugates mean that they have the same terms, a and b, but they have the opposite middle sign. One's plus, one's minus. We're going to use that to simplify these kinds of problems, the second type, which have, again, two terms in the denominator, one of which has an I. Since I'm going to simplify my denominator, I'm going to look here and I'm going to automatically see I have two terms, one with an I. Instantly, my first step is going to be my conjugate is 7 plus 5i. I'm going to multiply both numerator and denominator by that. The next step is to multiply both numerator and denominator by foiling. Now, we have a shortcut we can use for the denominator only. If I'm looking at, again, 7 plus 5i times 7 minus 5i. As we saw before, when you multiply these out, you'll get a squared minus b squared. So in this case, it's a matter of identifying what is our a, in this case it's 7, what is our b, in this case it's 5. We'd say, alright, we'll square that, and subtract. Now the difference is, with the original example, it was a plus b and a minus b. In this case, because of our i's, the effect is this is now going to be plus. And the reason is, if we FOIL this out, if I FOIL out 7 and 7, I'll get 49, minus 35i, plus 35i, and then minus 25, now I have I squared. 35i, negative 35i, will add to 0. So I have 49, and there's my a squared. 25, or minus 25, and I squared we substitute as negative 1, which becomes plus 25. So now plus, and there's my b squared. So the reason that works is when I FOIL, I'll get a squared plus b squared. So what we say when we give you just use a squared plus b squared, we're just skipping those middle steps and jumping right to the end. So in this case, my denominator is going to read 74. So I know my denominator, as I said, it's going to be 74. Now my numerator, for 99% of the problems, there's no such simplification shortcut will exist. So I'll FOIL it all out. Let's say 3 times 7 gives me 21. 5i gives me plus 15i. 2 times 7 gives me plus 14i. And then 5 gives me plus 10i squared. From here I want to simplify. 15i and 14i give me a 29i. Of course, I have 21. Now I squared is negative 1, so now I have 10 times negative 1, or minus 10. And when I combine my like terms, my 21 and 10, I get 11 plus 29i over 74. Lastly, I want to check, can I simplify my 11, my 74, and 29? In other words, is there a term that divides into all three of those? And in this case there isn't, so we leave it as so. And this is our final answer. So automatically I identify the conjugate of my denominator, multiply to the numerator and denominator, and then simplify as much as I can.